So hi everyone, Senan on this side, and in this video we are going to solve this two-sum LeetCode problem. This is the very first problem that is ever shown on the LeetCode page. So what this problem is asking is, given an array of integers and an integer target, return the indices of two numbers such that they add up to target. Okay, we need to find two numbers from this array so that their sum is equal to this target. Okay, fine. You may assume that each input would have exactly one solution, and you may not use the same element twice. Obviously, let's say if for some reason we have a unique element as 4 in our array and our target is 8, so we cannot return the index of this 4 twice to reach this target. That is what is asked in this question. And if this condition is not given, you may not use the same element twice, then you can return the same. But since this constraint is given, we would be taking this in consideration. You may assume that each input would have exactly one solution. So all the test cases that would be provided to you, it is guaranteed that there is one solution. You can return the answer in any order. Okay. So what I am thinking is, the very first approach that I would use is the two-pointer approach, and I can check all the pairs in this list and check if their sum is actually equal to target. If it is, we return their indexes. So for that I would use two pointers I and j, and to do that we need two for loops. But before that we need the size of this nums array. So nums.size, and what I do is, for int I is equal to 0, I less than n, I plus plus. Similarly for int j is equal to 0, j less than n, and j plus plus. Yeah. Now what we do is, before that, if you see that we are, since I is 0 and we are starting j from 0, so rather than starting from j from 0, we can start it from I plus 1. Why? Because if since we are just comparing the sum of two elements, if I is 1 and j is 2, or I is 2, j is 1, the answer would be same in both the cases. So this j plus j is equal to I plus 1 would ensure that you are not using the same element twice, and nothing. So yeah, let's now just check if nums of I plus nums of j is equal to target. What do? We return I and j. Obviously, since j is always ahead of I, the answer would always be in a sorted fashion. Now we are basically done with this question, but for the compiler will see that after completing this for loops, we don't have any return statement in this case. So it would not compile. It would ask that there's no return value for this function. Although given there is exactly one solution for all test cases, this would surely be executed at least once throughout this journey of testing this. But for the compiler, let's just write return and some any dummy value, -1, -1, and this should work. Okay, so this is working, and now let's just submit this and see if it is working or we have a time limit exceeded. Okay, this works, but before that, let's discuss the time and space complexity. So we are using constant space, so order of 1 or constant space we are using in this, and since we have two for loops and both are going linearly from 0 to n and I plus 1 to n, the time complexity would be order of n squared. Right. So that is about this. Now let's just copy this and comment this out, and we will see the next approach. So can we improve this? And I would say is yes, we can. For that we can use something known as the hash map. So we are compromising the space to get a better time efficiency. So I'll use unordered map, and type key value pair is int. Let's say since this is unordered map, we will use umap as its name. Okay, so what is this umap doing? Okay, so whenever we see an element, we will store that element in this umap, and the element would be the key and the value would be the index where we found that element, right? So what I can do is before that, let's say if nums of I plus some remainder is equal to target. If nums of I plus remainder is target, that means we have our answer, right? So currently, since we are at some I, so we have this value. We have a target also given. So what we need is to find if this remainder exists in this map or not. So what I can do is I can say int remainder is equal to what? Target minus nums of I. That is basic mathematics. And what you do is you basically find this in this map if it exists or not. Okay, so this if statement is true only if and only if we found that remainder, and if we did, that means we already have our answer. So what we do is we just return the values, which is what? umap of remainder and I. Otherwise, what we do is we insert this nums of I in the map. So umap of nums of I is what? We store the index as the value, right? Yeah, I think this should also work. So let me just check this once. Okay, so this is running, and let's just submit this and see if it works on all test cases. Okay, so we can see accepted. So yeah. So what is the time and space complexity in this solution? So in the worst case, what we could do is store all the elements in this map, right? So the worst case space complexity would be order of n. Obviously, we are going through one for loop, right? And inside this, since we are using unordered map, this on average searching would take big of an or constant time. And so all these three operations are constant time operations. So it would be linear time complexity or the order of n complexity. So in this case, we had n square. In this previous solution, we had n square time complexity, but space complexity was constant. To improve on time, we compromised the space, but we improved on time. See, you could obviously check this last time. I think it was somewhere around 40, and this time it is about 84, nearly twice the value. So this unordered map did help, but we compromised the space. So that was this video was all about. Hope you enjoyed this, but if you found any sort of value, be sure to subscribe. And yeah, if you know anybody that or who could use these sort of videos, be sure to share it with them. But anyways, bye.